Example 2. Compute the exact value of the function for the given x value without using a calculator.
Oh, no calculator.
I know, it's terrible. Whatever will we do?
Solve it.
Okay, so we're putting a 0 where x is. So 2 times 4 to 0. Hey, it's super important here that we remember our order of operations.
I mean, super does not...
Exponent
First.
comes before multiplication.
Yes. And just a point of clarification.
Okay.
The only thing that has an exponent on it is the 4.
Right.
Okay, just check.
This is 4 to the 0
times 2.
Yeah. So what is 4 to the 0 power?
It's 1.
Right. And we discussed that in the first example.
Yes. Anything to the 0 power is 1.
Anything ever.
Great-grandma to the 0 power?
Is 1.
It's 1.
Okay. 2 times 1?
Everybody knows it's 1.
2.
That's what I said.
Okay, so that's our answer. Let's try another one.
Let's do.
4 times 2 to the x, and we're going to put negative 3 there.
Oh no, a negative 3.
Well, let's review what we do with negative exponents.
Let's do.
We move them, if they're on top, to the bottom. If they were on bottom, we'd move them up to the top.
Indeed.
So this should be, the 4 is, it's fine. It doesn't have to move.
Again, point of clarification.
Yeah.
Where is the negative 3?
Just for the 2.
Just for the 2. Just the 2.
Okay, so the 2 cubed gets moved down to the bottom.
Right.
I know what 2 cubed is. Do you?
8.
It is 8 because it's 2 times 2 times 2. 4 over 8, we can simplify.
I know what that is.
Yeah?
Yeah. Do you know what it is?
I do.
Okay, let me see if you're right.
Okay.
Oh! Man, that was really close. I almost knew what it was.
Okay. And last, negative 3 times 7 to the 1/2 power.
I'm going to guess here that just the 7 has the exponent on it and not the negative 3.
Not the negative 3. Do you know what a 1/2 power means?
Yes.
Yes?
You want to write it down and see if I guess it right? That's exactly what I was going to say.
Right. Of course it was. So a 1/2 power means the square root.
Square root.
Those are the same.
1/3 would be cube root.
Cube root. Whatever number's on bottom, that's the root. Whatever number's on top is the power. So we could have like 2/3 and it would be a power of 2 and a root of 3.
Right.
But this here.
That's what we're done, by the way, because we're not using our calculator.
Right.
And square root of 7 is not something that we keep in our back pocket.
Nope, not in my back pocket.
Not in mine either.
Okay.
There's nothing in mine right now at all.
Okay.
Yeah.
Example 3. Determine formulas for the exponential functions f and g whose values are given in the table below.
Did you say f and g?
I said f and g.
Okay, all right. Just making sure.
Thanks. So let's start with f of x. So what we need for writing a rule like this is we need the initial value.
Yes, that's when your x is 0.
Right. So for both of these functions we're writing, we're going to need this value right here. That's the number that's in front. That's the a.
Right.
Okay. Then the base, the b, ends up being what we multiply by to get each step of the way here.
We're multiplying by 2.
Right. From 5 to 10, you multiply it by 2. Do another one to check. 10 times 2 is 20.
From 5/2 to 5 is by 2 because the 2's cancel.
Right. And so that's what our base is whatever we're multiplying by. Because
wow, that's
what we're
really
doing
easy.
Is like whenever we have a 1 that we put in, that's 2 to the first. When we put a 2 in, that's 2 to the second. All we did between those was times by an extra 2.
Right.
So that's F. Let's try G.
G. Oh, G.
So the initial value is 9. And then this one's maybe a little bit trickier. What do we multiply by?
I know. This one looks weird.
Yeah.
But you're multiplying by 1/3.
Right.
When you divide by a number, you multiply by its reciprocal. And in this case, we actually need the fraction answer.
Right. So that's 1/3 to the x. And it's really mathematically correct to put that in parentheses. You're saying all of that is to the x power.
Right, right. Not just the 1 and not just the 3.
Right. And so this brings us to, at the bottom of your page, you have this exponential growth and decay box. And it says, given an exponential function, and that a is a positive number, if b is greater than 1, the function is increasing and is exponential growth. If b is less than 1, then f is decreasing and is exponential decay. So these are things that are like real life kind of things.
Yeah, real life indeed.
Yeah, we will
half-life and double life.
Yeah, we'll talk about all kinds of things throughout this chapter that either have exponential growth or exponential decay. So like what you just said with half-life,
it's not the game.
They're not the game, no. Like with radioactive substances,
right.
They those radioactive parts of it decay at a certain rate, exponentially.
Right.
So that's
exponential decay. And bacteria grows exponentially.
Unfortunately,
So, unfortunately,
it does. Yeah.
yes, some of them grow really fast.
Yeah,
Okay.
I don't know what that's.
What?
Okay. So if we wanted to, we could say, hey, this one is exhibiting growth because the b is greater than 1. B right here is greater than 1. Here, b is less than 1.
Decay.
So that would be decay.
Yep.
There's probably going to be other examples.
I think there will be.
Well.